All right, so when we are talking about tangent and cotangent, the first thing that we're going to talk about is where these are undefined, okay? So to find the tangent, do you guys remember what you have to divide? Yep, so the tangent is y divided by x, the cotangent is x divided by y. So in order for something to be undefined, that means this bottom value is what? 0. So let's remind ourselves where those points are that have 0 in either the x or the y. So we have the point here that's 1, 0, and then negative 1, 0. Both of those are for the y. And then we have 0, 1 and 0, negative 1. Okay, so for the tangent, we're looking for where x is 0. So x is 0 here. What is that place in radians? Pi over 2. Okay, and then here would be 3 pi over 2. Now notice that these are directly across the circle from each other, which means they are pi radians apart. So the tangent function is undefined when your tangent value is pi over 2 plus pi times n. And that's going to cover every single rotation. So at pi over 2, if you were to add pi, right, it would hit 3 pi over 2, and then it would keep going back and forth between those however many rotations you needed. For the cotangent, this would be when theta is equal to, the first place is 0, the second place is pi. So generally we're going to use the first one, which is 0 plus pi n. But if you have 0 plus pi n, that's the same thing as saying what? Pi n. Great. Okay, now these values are going to be represented by something we've talked about before. They're represented by vertical asymptotes. So the tangent and the cotangent graph are going to have vertical asymptotes. So just like we did before, we are going to mark those on the graph with what type of line? Yep, a dashed line. Good. Okay, and if you looked at the characteristic box like I asked, you may have noticed some of the differences between the the tangent and the cotangent with sine and cosine. So one thing is, did you notice these all have arrows on them going up? That means that it's going to extend to infinity and negative infinity. So you don't have an amplitude. The amplitude is undefined. So that is one difference. Was there anything else in the information box that you may have noticed that's different? Yes, good. So for tangent and cotangent, your period is pi. And for sine and cosine, what was the period? 2 pi. Okay, great. So what that means is you repeat the cycle every pi units. Okay, and then if you look at tangent and cotangent, we can see with tangent, you are going to go up from left to right. And I'm just going to put from L to R. Okay, so you're going up from left to right, whereas the cotangent, you're going to go down from left to right. Okay, so this is your tangent function, this is your cotangent. If you were to isolate one of the curves of the tangent function, can you guys tell me what function family that looks like it's a part of? What type of function? Yeah, well, which one does this? X to the what? Third, x to the third, cube, right? Because quadratic is the parabola, right? Linear is a straight line. This is a cubic. It looks like a cubic function. All right, so we're going to put in the asymptotes here. So we talked about how the tangent function is undefined at pi over 2 and then every pi n units. So this is pi over 2, so we're just going to draw in that dashed line for the asymptote. Okay, you don't have to label it. And then if I go pi more units, I'm here. This would be at 3 pi over 2. Okay, and then the next one will be off the grid. And then we can go to the negative part. So we're going to put in our next one at negative pi over 2. And at negative 3 pi over 2. Okay, now if you look at the domain, the only thing excluded from the domain is pi over 2 plus pi n, because that's where it's undefined. Okay, and for this one, the domain, it can't be where it's pi n because that's where it's undefined. All right, so then let's put in where we have asymptotes for cotangent. So if we have pi n, remember we talked about the first place is at 0. So it is going to be right on the axis. So you might want a highlighter today to put in those asymptotes, or you can have a marker. Okay, and they occur every pi unit. So we have one at pi, we have one at negative pi, we have one at 2 pi and negative 2 pi. And it is a little bit off the grid, but we're going to go ahead and dash those in at 2 pi and negative 2 pi. Okay, so if the period is pi, if you just look at a unit of pi, like here for cotangent, it's a 1 curve. And then for this one, I think it's more helpful to look from negative pi over 2 to pi over 2. That is 1 curve. So every period has 1 cubic looking function, okay, or the reflection for cotangent. Okay, and the relationship between these is not only are they reflections of each other because you're going up from left to right versus going down, but you also have a shift in the graph. So remember, that's called a phase shift. All right, so it says, what are the x-intercepts on the graph of the tangent function? So I want you to look up at the tangent function, and there are 3 x-intercepts. I just want you to label what they are. So what are the 3 x-intercepts? And then on the cotangent, we have 4. So go ahead and label the 4 for part 2. What are the x-intercepts on the graph of cotangent? If you need some help, we are just looking here at the x-intercepts and we're just labeling those. So we're not afraid. Okay, so you have one at 0, at pi, and negative pi. Okay, so we can just list those out. Those are my x-intercepts. And then for cotangent, do you guys know what this guy is here? Yep, this is negative 3 pi over 2, negative pi over 2, and then we have the positives as well. So negative 3 pi over 2, negative pi over 2, pi over 2, 3 pi over 2. Okay, we are going to be using these today when we are graphing to help us with our patterns. And I want you to notice that this is going to start at 0. Remember how when I say start, I mean 0 or above, because that's the easiest thing to remember when you're doing your pattern. So they're going to start at 0 and occur every how many units? Yep. So they repeat every pi units. Remember, we talked about the period is pi. That is the significance. They're going to occur once every period. So the way that we would write that as an equation is 0 plus pi n. So 0 plus pi n, which is the same thing as just pi n. So when you are asked to write an equation, these are the x-intercepts for the tangent. Okay, so that was one thing that you guys had to do for your homework last night with the sine and the cosine, okay, some people did not label that. So I need you to make sure you're reading directions carefully. Okay, if it asks you to name the x-intercepts, then you need to come up with an equation. Okay? Okay, and then for the cotangent function, again, we're just going to start at the positive one. So the first positive one would be pi over 2. And then again, it repeats every pi units. So what I'm doing here is I'm helping you guys see what your pattern is. Hey, generally you kind of figure this part out on your own, but I think it's helpful for you to start with a positive and then look, it's repeating every pi. So you can always write an equation where you're starting with that first one, and if it's every pi units, we just do pi times n, and these are going to be the x-intercepts for the cotangent. So the x-intercepts for tangent and cotangent are different. Okay, and then we have a few information boxes. These are going to help us find the asymptotes. So we have an information box for tangent and cotangent. I just like to write this above so that when you're going back and you're looking for this information, it kind of sticks out to you. Okay, so it says the period is pi over the absolute value of b. We have talked about before that it's common to write it like this. The period is pi over your b value. And if you look at cotangent, it's the same thing. All right, so that's similar to sine and cosine. Sine and cosine was 2 pi over b for both of them. So tangent and cotangent are both going to be pi over b. Now, if you look at the equations for the asymptotes, they are different. And that is going to relate back to what we talked about above. Sorry about that. All right, so for our equations, okay, we are going to use these because they're going to ask you for your asymptotes. So the asymptotes are located at, and again, they use this absolute value. I don't know why, but I just feel like that looks like a lot is going on. So we're just going to rewrite them without it. So this is pi over 2b plus pi n over b. And then after you write that down, I want you to look back at the first blank that we filled in. The first blank we filled in was where you had values that were undefined. Let's look and see how those are related. Okay, so in the first blank, you have pi over, you have theta was equal to pi over 2 plus pi n. What's the only difference? You have the b, right? And that's because b is a horizontal shift, and that is what is going to make it change. Okay, so your b value is not always going to be 1. I know that yesterday for your phase shifts, you did have your b value of 1. Okay, but for these, you're going to have different values of b, and they're going to move the graph. So they're going to stretch it, and they're going to compress it. Okay, so all that's happening now is we have this divided by b, so we have to take those horizontal transformations into account because those are going to affect the period and the asymptotes. Okay, and then for the cotangent, you have x equals pi n over b. And again, if you look at that second blank, which is where we talked about the cotangent, we had pi n. So again, we are just dividing by b, which is equivalent to the reciprocal of b. And so we are going to be talking about the reciprocal. All right, so you're going to have to find the period, you're going to have to find the equation for the asymptotes, and then you're also going to have the equation to find the x-intercepts. So I gave you what they were for the parent function. Okay, for the parent function, it was pi n and pi over 2 plus pi n. and it was pi because that was your period. What you're going to do for an equation that doesn't necessarily have pi as your equation is you are just going to find the first x-intercept. So the x-intercept is going to be the first x-intercept plus the period multiplied by n. That way, if your period isn't pi, you are just going to plug that in there. Okay, and it's just your first x-intercept on the positive axis, okay, or at 0. All right. Once you have that written down, we're going to take a look at example 1 that it accidentally says example 2. Well, the reason why it says example 2 is because yesterday we did example 1. But I don't know, I kind of would like it to say example 1. All right, so we're going to use tangent of x or cotangent of x as a guide to graph these functions. And then we are going to graph these. We're going to identify the period, x-intercepts, and the asymptotes. Okay, so the first thing I want you to do is identify the period. If you can write down the b value, that would be excellent. All right, so Ali, what'd you get for your b value? 1/3. Yep, so it's 1/3. So when you are finding the period, okay, see, I put these on this page for you so you didn't have to flip back and forth. Isn't that so sweet? Don't you guys hate flipping back and forth? I do not like it. I don't like it. Okay, so we're just going to do pi over b. Okay, so pi over 1/3. If you're dividing by 1/3, it's like you're multiplying by 3. Okay, so your period is going to be 3 pi. Okay, so it said identify the period. We did that. Okay, the next thing we're going to find, it says the x-intercepts. So when it asks you to find the x-intercepts, they want an equation, and we're going to do that. But when you're graphing it, you also want the actual intercepts so that we can graph those. So on our graph of the tangent, I'll show you guys mine. So on the graph of the parent function, where is our first x-intercept? 0. So our first x-intercept we'd say is here at 0. So it occurs at 0. And because our period is 3 pi, we're going to use our equation for the x-intercepts. And we actually wrote that down below. So like it wasn't in your box. So remember, the x-intercept is just your x-intercept plus the period times n. Okay, so if you have 0 plus 3 pi n, that's the same thing as just saying 3 pi n. Okay, so this would be your answer for the x-intercepts. Now this question that I'm prompting you below is so that when we get to the graphing stage, we have specific points and not just an equation. There are a couple different ways to find the intercepts, but when you have different phase shifts, you are going to want to do this by using the reciprocal of b. If not, then you end up with your x-intercepts and the asymptotes in the same place, and that's when confusion steps in. So to avoid that, we are going to use this method where we are going to use the x-intercepts of the tangent graph, and then what we do is we multiply them by the reciprocal of d. All right, so we are going to write out the x-intercepts of the tangent of x. Okay, we're just going to list them here. And when you're doing this on your own for your homework, you've already listed them, so you can just take these three. Negative pi, 0, pi. Okay, so negative pi, 0, pi. And then when you multiply them by the reciprocal, your b value is 1/3. So what's the reciprocal? 3. Okay, so we're going to multiply by reciprocal. So we're going to times 3 times 3 times 3. Okay, and we're writing these out here to help you so that when you look back, it's easy to follow. Okay, and then we're just going to multiply straight across. So negative pi times 3 is negative 3 pi. 0 times anything is 0. 3 times pi is 3 pi. So these are going to be the 3 intercepts you are going to put on your graph. All right, and then we are going to identify the asymptotes next, and you do have an equation for that. So for the asymptotes for tangent, it's x equals pi over 2b plus pi n over b, and we are going to plug in 1/3 as our b value. And then I'm going to have you simplify that. Okay, so write what your simplified version would be for your asymptote equation. All right, so 2 times a third is 2/3. So when you multiply that by the reciprocal, okay, this is going to be 3 over 2 pi. Pi n divided by 1/3 is going to be written as, yes, great. Okay, and then you always need to do the x equals because an asymptote is a line. And this is telling you that this is going to be a vertical line. Okay, so these are your equations for the asymptotes. Now, just like we did with the x-intercepts, you have an equation, but you also need to find where they actually are on the graph. And this is going to help us with our scale. So when you're doing the asymptotes, you are going to plug in values to find what the asymptotes are on your graph. Okay, so I am going to summarize the information here so that we can come up with a good x scale. When you're doing this, you're going to have it all kind of together. This is just spread out, so I want to talk about it. Because if you were just using your x-intercepts, you might think it's fine to use the scale of pi, and that would make some of the other points difficult. Okay, so with your asymptotes, we have to take those into account as well. And so your equation is the x equals the 3 pi over 2 pi plus 3 pi n. We are going to plug in values for n to find the actual asymptotes. And the best values to use are -1. Oh, sorry, let me delete that. So I replaced my mistakes with little hearts. You know, like Bob Ross replaces his mistakes with happy little clouds. I do happy little hearts. Okay, so when you plug in -1, 0, and 1, that is going to tell you where the asymptotes are on your graph, okay? So if I do n is equal to 1, I have 3 over 2 pi plus 3 pi times -1, and I'm going to go ahead and I'm going to simplify that. And then that's going to let me know where I can put this on my graph. So this is going to be 3 pi over 2 minus 3 pi. If you're combining those, what do we have to get in order to subtract them? Same denominator. So if this is over 1, we're just multiplying each one by 2, right? So this becomes 3 pi minus 6 pi over 2, which is -3 pi over 2. Okay, so now we're going to do n equals 0, which is our favorite, because if n is 0, what are you going to be left with? Yeah, so you can just write that, it's fine, okay? And then let's do 1. So you have 3 pi over 2 plus 3 pi. I want you guys to simplify that, and then think about what our x scale should be. There's not necessarily one right answer. Okay, so remember, we're just adding these together. That's very similar to what we did in 11.1 and 11.2. Remember how we had to add 2 pi and subtract 2 pi to find those coterminal angles? Okay, so that helps us when we get to this stage, because really, if you have this over 1, it's times 2 times 2, so you're adding 3 pi plus 6 pi over 2, which is 9 pi over 2. Okay, do you guys want to tell me what you think are some good scales? So we want to hit this 3 pi, -3 pi, and 0, but we also need to have the 3 pi over 2, the -3 pi over 2, and 9 pi over 2. So what are we thinking? You could do that. Mm-hmm. Yeah. Could do 9 pi over 2, but then you have to do like halves, right? Yeah. Okay. Yeah, that might be a little difficult. So, right, like if you went every one is 9 pi over 2, you were hitting 3 pi over 2, the scale.
Like, oh, sorry, I meant go out to pi over 2 as your maximum.
Oh, yeah, we are going to have our 9 pi over 2 as a maximum. Okay, so you could do 3 pi over 2, or I would just do pi over 2, because that's going to help you hit everything you need to. And you also aren't going to have to do a bunch of different waves. So we can do 1 pi over 2. What's 2 pi over 2? Pi. And then I'm going to label 3 pi over 2 because that's one of my key points. 4 pi over 2 is 2 pi. I'm not going to label that. 5 pi over 2. 6 pi over 2 is 3 pi. 7 pi over 2. 8 pi over 2. 9 pi over 2. Okay, you don't have to label every single one, but you do need to label some of your key points on there. And same thing with this side. So you have -1 pi over 2, -2 pi over 2, -3 pi over 2, 4 pi over 2, 5 pi over 2, -6 pi over 2 is -3, -7, -8, -9 pi over 2. Okay, spanning the graph. So the points that we have are going to help us get started. Okay, so I want you to look at the x-intercepts. So we have -3 pi, 0, and 3 pi, and I want you to mark those off on your x-axis. Okay, so after you've labeled these, I want you to do the -3 pi, 0, and 3 pi. Let's see. So you have 0, you have 3 pi, you have -3 pi, and then a pattern should be emerged. So 1, 2, 3, 4, 5, 6. So between these, you have 6 units. 1, 2, 3, 4, 5, 6, 6 units. And then if I had the space, I would have to keep going those 6 units, and I would have to fill in the other x-intercepts. For this graph, though, you've spanned all of the x-intercepts on this window that we've created. The next thing we're going to put in are the asymptotes. So what we want to do is we want to start with that -3 pi over 2. And you can use a marker or a highlighter, just something that shows up. And you have a dashed line. And then we have 3 pi over 2. And really, once you get 2 of them, you should be able to see what the pattern is. The 3 just really solidified that. So you can see that these occur every 6 units. So I don't have all of the asymptotes on the graph yet. I can fit one more in. If I go 1, 2, 3, 4, 5, 6, you have one more here. So you need to put enough in to span your graph. Okay, so we've labeled these units on our graph. Remember that if it is a tangent, it is going to go up from left to right. Okay, will you guys watch me do the first one, and then I will let you do that. So with these graphs, some of them are going to be narrower, some of them are going to be wider. When you are making this curve, you are actually making half of a parabola going up and half of a parabola going down. So the half of the parabola going up is going to look like this. It should not cross the axis. And then the other half is going to be going down. So this is like half of a U. Okay, so half of a U going up, half of the U going down. And then we're going to do the same thing for this one. So it should be following that asymptote. You do have a horizontal stretch here, which means the graph is being pulled apart. And that's why you have these thicker graphs. Okay, they're wider. And then once you have those, you can go ahead to part B and you can identify the period and you can start to find your x-axis. Okay, so I want you to do step 1, and then I want you to see if you can use your pattern to do step 2. Okay, so what did we get for the period for this? Good. So your b is 3, so the period is just pi over b or pi over 3 for this one. Okay? All right, and then it says on the graph of the cotangent, an x-intercept occurs at, and then let's just find the first one that's positive or 0. What's the first one that's positive or 0? Pi over 2. Okay, and if you were not sure about that, you just go back to our list, right? What are the x-intercepts on the graph of the cotangent function? We wrote all of these down. This would be the first positive one at pi over 2. Okay? So because our period is pi over 3, remember to do the equation for the x-intercepts, it's always going to be that first x-intercept plus the period multiplied by n. So do you guys think you can write that equation just using that structure? I'm feeling good about it for you. Okay, so the x-intercepts are going to occur at pi over 2 plus what? Yeah. And you can either do pi n over 3 or pi over 3n, that doesn't matter. So this would be your equation for your x-intercepts, okay? Now, when you are finding these, okay, you do need to use the x-intercepts of the cotangent. And like I mentioned on the earlier one, there are multiple ways that you can do this, but this way is always going to work, which is why I like to show it to you this way, okay? So if we look at the x-intercepts of the cotangent, we wrote down 4. We wrote down negative 3 pi over 2, and then negative pi over 2, pi over 2, and 3 pi over 2. You don't have to do all 4 of them. We're just going to do 3 of them and then follow the pattern. Okay, so we are just taking the x-intercepts from the cotangent. So negative pi over 2, pi over 2, and 3 pi over 2. Okay, we're just taking those from the parent, and then we're multiplying by what? Multiply by, and yeah, so if b is 3, what's the reciprocal? 1/3. Okay, so we're going to take all of these and multiply by 1/3. All right, so we just multiply straight across. So this would be negative pi over 6. Pi times 1 is pi. 2 times 3 is 6. 3 pi times 1 is 3 pi. 2 times 3 is 6, but that can reduce to 3 pi over 6 is pi over 2. Okay, so these are the 3 we're going to put on our graph. So I alluded there's another way you could do this. Do any of you know what I'm talking about? You can plug in values for n, okay, and that's going to work sometimes, just not all of the time, okay, because when there's different types of transformations, they affect that, but you can always use this, all right? Okay, so now we're going to identify the asymptotes. And again, these you have to use the cotangent for, and you still multiply by the reciprocal. You have the cotangent and you have the tangent. All right, for the asymptotes, for cotangent, again, they're right here, so we're going to use this equation, pi n over b. So if x equals pi n over b, and we plug in 3, then x is just going to be pi n over 3. So when you're doing this, you're going to have the period, you're going to have the x-intercept equation, and then you're going to have the asymptote equation. What I'm going to do is I'm going to use this space here to find the values. So we're going to plug in n is 1, n is 0, n is -1, and +1. So can you guys plug those in and find your 3 asymptotes that we're going to put on the graph? Then we're going to gather our data, and we're going to determine our scale. All right, so when you plugged in -1, you just have pi times -1 divided by 3. So what's that? Yeah, -pi/3. Okay, if you plug in 0, you just get 0. If you plug in 1, you get pi/3, right? Easy peasy lemon squeezy. That always saying always makes me want hard. Okay, so now what we're going to do is we are going to compile that information. So the x-intercept, we have -pi/6, we have pi/6, and we have pi/2. The asymptotes, we have -pi/3, 0, and pi/3. And I'll leave it on for this question. We've already discussed it. Okay, but I want you guys to think about what your scale should be so that we can hit pi/6, pi/2, and pi/3. Right? If you count by pi/3s, you have 1 pi/3, 2 pi/3, 3 pi/3, which is pi. If we count by pi/2, we have 1 pi/2, 2 pi/2, which is pi. If we count by pi/6, you have 1 pi/6. What's 2 pi/6? Pi/3. What's 3 pi/6? Pi/2. So what's our scale? Pi/6 is what I would do. Does that make sense? The pi/6 part? You want to count by something so that you get all of these key values in here. Okay? So that's why we do want to count by pi/6. So we're going to start labeling. So 1 pi/6, 2 pi/6 is pi/3, 3 pi/6 is pi/2. And just like I'm counting out loud to you, I am counting in my head to myself as I'm doing these, because when I'm saying that, I'm thinking of the reducing after. So 1, 2, 3, 4 pi/6, 5 pi/6, 6 pi/6. So I know that those aren't any of my key points, which is why I skip them. You can write them down, okay? So this is 2, 3, 4 pi/6, 5 pi/6. You guys know what 4 pi/6 reduces to? Yep. Also, this is like 1 pi/3, 2 pi/3, 3 pi/3. This would be 4 pi/3. So you can also think of it as every other one, you're going by pi/3. So -1 pi/3, -2 pi/3, 3. But I also want to label my -pi/6 because I'm going to put something there. the first thing we're going to put on there are the x-intercepts. Okay, I do recommend like putting them on in pencil first, and that way when you go to put your asymptotes on there, if you notice that they're overlapping, something went wrong, because they should not be overlapping. Okay, so the x-intercepts, you have pi over 6, negative pi over 6, pi over 2. So let's identify what the pattern is. You have an x-intercept every how many units? Yep, occur every, I'm going to write 2 units on the graph. Okay, which is, yes, every pi over 3. Okay, it's okay if you aren't thinking about that. You don't have to identify that. What you do have to make sure you do is span the graph. So you have these 3, and then we're just going to count 1, 2, we have another one. 1, 2, another one. TJ College would be so proud of us. And another one, and another one, and another one, and one more. Okay. So once you have those, now we're going to do the asymptotes. And when we put these on our graph, I'm at 0. So this might be a highlighter situation. Okay, so we're going to put one on there at 0. And then I have it pi over 3. Again, where I'm putting the dash line on there. And then I have it negative pi over 3. So once you have those, look and see how many units those are. How many units have I done? Every asymptote occurs every how many units? 2. Okay, so let's keep up that pattern, and then we'll do the next thing together. So every 2 units, we're putting that dash line until we cannot dash any number. Okay, so we're going to keep that on. Another one here. Okay, so we are graphing multiple cycles here. Do you guys know how many cycles we graphed on the last one? So one cycle is 3 pi. And if you look at 0 to 3 pi, see how you have one up and one down? It's one cycle. This is one cycle. So we graphed 1, 2, 3 cycles there. Okay, we are going to graph several cycles here. And I'm going to help you with this. So you can just watch me do the first one, and then I will let you continue. So if it is cotangent, remember it goes down from right to left. So when you do this, this is going to be more narrow. So we're going to curve it up, and then we're going to curve it. Oh man, did I? Pencil. Thank you, Daddy. I even did the thing where I told you guys. Somebody had a whiteout pen today, and I put it on my wrist because I was like, oh, I always mess those ones up. Okay, so when you do cotangent, let me make my little thing mark. Okay, so we're going to curve up, and then we're going to curve this one down. We're going to curve this one up. We're going to curve this one down. And I know when you have this many cycles, it is easy to get a little sloppy, but we are not going to do that. We're going to stay diligent. We're going to take our time so that we have the up swoop and then the down swoop. Down swoop, up swoop, down, up. And again, this is just going to follow those asymptotes. So what you had here is a horizontal compression. So it pushes your graph together. And then you are still going to, when you have this, because you do have this intercept here, okay, you are still going to keep that little tail there. Okay, and how many cycles did we graph here? Yeah, so if you have the 2 halves, it makes it 9. Okay, now for your assignment, I did not alter the box for this. You do not have to put anything in the box. If you would like to put in the box the x-intercepts, you can. If you'd rather write those on the side, that is fine too. Okay, but you don't have to do the 5 points like we did before. If you guys want to put the asymptotes in there and the x-intercepts, you can. Okay, if you are going to miss tomorrow due to an AP class or maybe a unified sports thing, I was trying to think what else is going on tomorrow. Okay, then what you need to do is you need to finish this. This is not due. Are we listening? This is not due until Friday morning. Tomorrow, we're going to finish this, and we are going to start our review. So if you know you are not going to be here tomorrow, I will give you that review, because this assignment will not take you all of the class period tomorrow. Or when you come back here, maybe you can take one and pass that over. Okay, and I know a couple of you. So I gave you guys the graph sheet first, and then this is your practice sheet. Okay, so this is not due till